Hello and welcome to this video on complex numbers. This is the last part of theory, which is the fourth video. So again, I'll say that a lot of this will not make sense to you if you are new in class 11th. So bear with me, and when we will solve problem, all of this will become clear. For example, you wouldn't know what is a determinant and how do we solve this. So when we will study determinants, you can come back to this and understand that. For example, length of perpendicular, you won't understand this as such. When you study coordinate geometry, you will have more sense into this. So length of a perpendicular of a point A, which is represented by complex number omega from the line A bar z plus AZ bar plus B is equal to 0, where A is in complex number set and B is in real number set, is given by P is equal to mod of A bar omega plus A omega bar plus B by 2 mod of A. The equation of a circle is given by z minus z0 is equal to r, where r is the radius and z0 is the center, or z is equal to z0 plus r e to the power I theta, where theta is in the range of 0 to 2 pi. Now, if you square both sides over here, from our modulus formula, if you recall, it will be equal to z bar minus z0 bar minus z0 bar z plus z0 bar minus r square is equal to 0. Now the general equation of the circle is given by z bar minus az bar plus az bar z plus b is equal to 0, such that square root of a bar minus b is equal to 0. Center of this circle lies at point minus a and radius is a bar minus b. An equation to the circle where the diameter is the line segment formed by joining z1 and z2 is given by z minus z1 into z bar minus z2 bar plus z bar minus z1 bar into z minus z2 is equal to 0. Now, an equation of a line passing through 2 points z1, z2 is given by this equation, where k is a parameter. Equation of a circle passing through 2 points. So suppose we have 3 points A, B, and C, and a circle passes through that. So we consider 2 points P, this PZ and PZ. We don't consider 2 points, it's a point in 2 different segments. So this point is in the same segment as C, and this point is in a different segment than C. So if you consider this point, then because P and C are in the same segment of chord AB, so APB will be equal to ACB, and since this is in a different segment, ACB will be plus APB will be equal to pi. So that comes from geometry. Now, if this is the case, then we have this equation or this equation. So in both the cases, okay, in both the cases, the fraction must be purely real. Now, the fraction has to be purely real. Then from the property of conjugates, we know that z should be equal to z bar for any complex number to be purely real. Once you apply that, you will get the condition for 4 concyclic points also. Now, suppose we have this argand plane, this y is at wrong place. There is x-axis, there is y-axis, and we have a line segment passing through z and z0, making angle alpha with the x-axis. Then the argument of z minus z0 will be equal to alpha. So if z0 is at origin, this equation, this point moves to origin, then it becomes argument of z is equal to alpha. Now suppose we have 2 points A and B, and there is a point Z such that Z minus Z bar is equal to Z minus Z2 bar. Then Z will represent the locus of this vertical line, and this will be perpendicular bisector of this segment. So this is equal to Z minus mod of Z minus Z1, this will be equal to mod of Z minus Z2. So you see how this will form into picture. So pick any point on this vertical line, it will satisfy this equation. Now also, if k is greater than 0 and k not equal to 1, and the ratio of these two modulus is equal to k, then it represents a circle. There are few more equations we have to go through. I'll suggest that you just try to go through this, because for example, you don't know what an ellipse is right now. So let's see. Let's just read through these so that we can use this in our equations. So consider z minus z1 plus z minus z2 is equal to k, where z1 and z2 are two fixed points and k is a positive real number. If k is greater than z minus z2, then this represents an ellipse with foci at z1 and z2, and k is the length of major axis. If k is equal to z minus z2 mod of z minus z2, then it represents a line segment joining z1 and z2. In case k is less than z minus z2, then it does not represent any curve. Now we put this minus sign in place of plus here, like previous case, and if k is not equal to z minus z2, then it represents two parabolas with foci at z1 and z2. If k is equal to z minus z2 mod of z minus z2, then represents the line segment joining a and b but excluding the segment AB. And if we have square of mod of z minus z1 and z minus z2 mod square is equal to z1 minus z2 mod square, then it represents a circle with z1 and z2 representing the diameter. Now we consider argument of z minus z1 by z minus z2 is equal to alpha, where z1 and z2 are two fixed points. Alpha is a real number such that it is between 0 and pi. Now if alpha is between 0 and pi and not equal to pi by 2, then it represents a segment of circle passing through z1, z2. So you have a circle, you take a segment that will make an angle alpha over here, that is equal to, that is this condition. If alpha is equal to pi by 2, then it represents a circle with diameter as the line joining segment z1 and z2. So you know that in a circle, the diameter makes an angle pi by 2 on the circumference. So in this condition, z1 and z2 will represent the diameter. If alpha is equal to 0, then it represents a line segment joining z1 and z2. So you have one line, then angle made between these two will be 0. So that's what this condition is. If alpha is equal to pi, then it represents the line segment joining z1, z2 but excluding z1, z2. So you have one line here, you leave some space, you have another line. So the angle between these two lines is pi by 2, pi, not pi by 2. So with this, we come to the end of theory of complex numbers. And if you ask me, I hated making these videos because a lot of this just can't be explained to a new student of class 11. So once we start solving the problems, and slowly your imagination will grow as you study more and more on class 12, the change of complexity of problems from class 10 to 11th and 12th is drastic. Problems certainly become a lot more complex as you move into class 12. So I hope you have found this video useful and informative, and if you have a question or comment or suggestion, then leave me a comment, and please subscribe to the channel and like the video so that it can reach many more people and more students can benefit from this. And with this, we come to the end of theory of complex numbers. I'll see you in the next video. Enjoy.